Hi guys, welcome to my channel. In today's video, we're going to be talking about the histological structure of the different vessels in the body. So, in the whole cardiovascular system, there is always a common histological structure. So, whether it be the heart right here, so this is the structure of the heart, or any vessel in the body, they both have a common histological structure composed of 3 layers. So on the inside, we always have this epithelial layer that is in contact with the fluid inside of that organ or that vessel. So whether it be blood or lymph. So this epithelium is specifically called endothelium. Okay. And then the second layer in the middle, which is this layer, this is a muscular layer. It's basically muscle that contracts. And then on the outside, we have a connective tissue layer, which protects the organ or the vessel. And so this is a connective tissue layer. So in the past, I already made a video about the histological structure of the heart. And if you saw that video, or if you basically know the structure of the heart, you already know that the innermost layer, the endothelial layer, is called the endocardium, and the muscular layer is called the myocardium, and the connective tissue layer is called the pericardium. Now, for the vessels, on the other hand, they have different names. So the innermost layer is called the tunica interna, or the tunica intima. So intima, like this. I'm sorry for my handwriting, by the way. And then the muscular layer is called the tunica media. And then the connective tissue layer is called the tunica externa, or adventitia. In today's video, I'm going to be specifically talking about the general structure, the histological structure of the vessels. I'm not going to go in detail about the different types of arteries or veins or lymphatic vessels. So I'm going to make a video specifically about each of them, as well as capillaries. So just stay tuned for the next videos where I'm going to be talking about these different structures. So today is just going to be like the general structure. So let's start with the innermost layer, the tunica intima or interna. So this is the tunica intima. So it's this layer. So what we have here is basically an epithelium, and we add to that, like any epithelium, it has a basal lamina. Okay, so basal lamina, and underneath this epithelium we have a connective tissue. Okay, so here it is. So we have the epithelium. So the type of epithelium is a simple squamous epithelium. So we have one layer of cells that are flat or squamous. And underneath it, we have the basal lamina, or the basement membrane. And underneath it, we have the connective tissue, a thin layer of connective tissue, the subendothelial connective tissue, which comes underneath the endothelium. And yeah, so let's talk about the endothelial cell. So this is like a simple representation that I made by myself. So let's look at the structure of this cell. As you can see, it's a very small cell. It's flattened. It has one nucleus, and it has like all the organelles, the common organelles that you find in any cell, basically. And yeah, so what's specific about this cell is that when we look at the inside of this cell, we find 2 types of things. So we first of all find these things, which are vacuoles, pinocytosis vacuoles. So if you don't know, pinocytosis is basically the process of a cell when it takes like some substances from the external environment, and it internalize it gets it inside of the cell, inside of this vacuole. And what this means is that, this cell can actually take some substances in the fluid, so basically the blood, and it takes it inside of the cell. Okay, and we find other types of things. So these are some granules, so these are some storage granules. So these storage granules are basically granules that have inside of them substances that the cell has, fabricated, and they're just staying there for the time when we need them and when they're going to be released. And these are called the Weeble Palladi bodies. So here's just one L. Sorry for this mistake, but they're called Weeble Palladi bodies. And what the substance that these bodies can contain is called the, just in a second, it is called the von Willebrand factor. So I think it's spelled like this. I'm not sure though. So brand with a D. So factor. So this is basically a factor that has like a big, function in the clotting, and yeah. So basically, this cell has a lot of functions. It's not just an epithelial cell that is just there to protect. It also has a lot of functions. And so you can conclude from this that this layer is super important. Not only is it a barrier, like a physical protection, it is also so it also serves as a selective barrier, so it can allow certain cells or certain substances to go through it to the other layers, and it cannot allow other things to go through it. And that's because it has certain like specific receptors on top, like on its surface, which actually allows it to have very important functions. It can regulate the immune responses and inflammatory responses. It has an effect on the constriction or dilation of the vessel. It can have that's she can like the cell can do that by acting on the smooth muscle cells on the tunica media, and it has so many functions. Now for the second layer, it's the tunica media. It is a very thick layer. It is actually the thickest layer in arteries, and it is the second thickest layer in veins. So in veins, the thickest layer is actually the tunica externa. So this layer is just generally speaking pretty thick. It is composed of a smooth muscle. So here in this picture we have like this smooth muscle that is shown. So here you have how like this picture shows how the smooth muscle cell contracts, and so this layer is composed of smooth muscle, and between the smooth muscle cells we have connective tissue composed of elastic fibers. So basically this layer is smooth muscle plus elastic fibers, and the proportions between the smooth muscle cells and the elastic fibers actually differ from one vessel to another. So if you take, for example, the arteries, there are certain types of arteries that have way more elastic fibers than smooth muscle fibers, and other arteries that, on like the opposite, have more muscle cells. And this gives, different functions to the vessel, obviously. Now let's move on to the last layer, the tunica adventitia. It is also a pretty thick layer. It is composed of a very tough connective tissue. Oh, sorry. So it is composed of a very tough connective tissue with a lot of collagen fibers. And like I said earlier, this layer is for protection. And it's actually inside of this layer that we find, the little nerves and vessels that irrigate the vessel, actually, because you might wonder, like, how does a vessel get its blood supply? Well, it's actually a little bit complicated, so I'm going to be talking about it, actually. So how does a blood vessel get its nutrients and its oxygen that it needs? So this depends on the vessel. So if we're talking about large vessels, so if the vessel has a diameter of over like 1 millimeter or something, it has actually some tiny little vessels that irrigate it, and these are called vasa vasorum. So these are like super. It basically means the vessel of the vessel. So if we're talking about like a small vessel, it doesn't actually need the vasa vasorum because it can actually get its nutrients from and its oxygen from the blood in the lumen through diffusion across small distances. So the blood can actually diffuse between the cells through small distances, and they can get their blood supply. But when it comes to large vessels, the blood can't actually reach the outer parts of the vessel through diffusion, and this is when they need the vasa vasorum for the blood supply. So we actually have three types of these. So we have three types. We have the vasa vasorum externa, we have the vasa vasorum interna or internae, and the vasa vasorum venosum. So the difference between these types. So let's start with the intern ones. So these ones, as you see in this, very beautiful drawing that I found on Google, we have the vessel that actually starts. So this is the lumen of the vessel, and these are the three layers. Okay, and so the little tiny vessel here starts from the lumen of from the main lumen of the vessel itself. So it starts from the vessel itself, and it goes to the different layers. The externae, on the other hand, they don't generate directly from the lumen. They actually generate from another vessel, like right here, for example, which gives us these, and these will go and nurture, the main vessel. So as an example, we have some vasa vasorum that come from the intercostal arteries to the aorta, and the intercostal arteries actually come from the aorta by itself. So I hope this is clear, but like basically we have, this is the intercostal artery and this is the aorta. Okay, and the aorta actually in another place, it actually gives the intercostal arteries, and then the intercostal arteries will give the vasa vasorum of to the aorta. Okay, so yeah, this is the external one. And then for the venous ones, so these are basically like the vein side of the vasa vasorum. So these are like arteries, they give oxygen and nutrients, and these are the drains, the veins that drain that blood, and they drain it to the vein here. Okay, so these are the three types of vasa vasorum that we find in the vessels. I think this is all. Actually, I haven't talked about the innervation of the vessels. So for the innervations, the nerves are found within, the outermost layer, the tunica externa, and these fibers are mostly sympathetic fibers, which regulate the constriction and dilation of the vessels. So the sympathetic system can cause a constriction and a dilation of the vessel. And in certain vessels, we can also find some parasympathetic fibers as well. So these fibers innervate the outer muscle cells, so they go inside of the tunica externa, and then they reach a little bit the tunica media, but just on the on the outside part, and they innervate certain outer cells, muscle cells, and then the stimulation propagates inside of the tunica media to other, like from one cell to another, through the gap junctions, and this is how the constriction happens. So I think this is all. I hope this video was helpful. If it was, please don't forget to leave a like and leave a comment, and maybe subscribe to this channel for more content, and good luck on your exams.